Hi all, now we are going to see the Dyna Q architecture, how the Dyna Q algorithm works. Before going to see what is Dyna Q architecture, the prerequisites which are required to understand the Dyna Q architecture we are going to see. First one, we already know what is model based RL and model free RL. So model based RL means, so here the environment, it is already fixed, everything it is planned. Just like take the example of any our chess games. In the chess game, if you see, already the model, it is there, existed, we planned, we constructed the model and we developed the environment. So it comes under model based RL. And take the example of Google Map. In the Google Map, suppose if you are taking for example of Chennai city, entire Chennai map, you have modeled the environment of the Chennai city. So those are the examples comes under model based RL. So it means how we are creating the environment in the model based RL by using simulation. So for the chess game, the rules, everything you're simulating the environment of the chess game. For the Google Maps, whatever city you need, you are just simulating the you're simulating the environment of that particular city. Those examples comes under model based RL. And when coming to model free RL, here there is no environment, there is no model. Agent learns from its different experiences, like trial and error. So everything he does, some actions, he performs some actions. Based upon the actions, he will get some rewards. So based upon the rewards, he will understand and he will build the model. So everything the agent learns from the experiences directly without knowing any environment. So example, like suppose I'm going to new city, but I don't have any map, I don't have any idea of the city. By visiting different places, I will understand the city. So this example comes under model free RL. Model based means model, we have already created the model by using simulations. Model free means no model is there, just trial and experiences. We are getting some rewards. Based upon the rewards, we are constructing the model. So when coming to Dyna Q, normally if you see model based, it has its own pros and cons, and model free, it has its own pros and cons. If you see model based, no, so we have to create the environment by using some simulations. So to creating the environment from the simulations means it is computationally little expensive, it is little bit more cost. But model free, no environment, nothing. But here you are not spending any money, it is very cheaper than compared with the model based RL to create the environment. But model based, everything rules, everything it is predefined, fixed. So learning to the agent is very easy. But in model free, no rules, nothing, no plan. So here agent takes more time to understand. So both model based, model free has its own advantages and disadvantages. When we are coming to the Dyna Q, it is a combination of both model based RL and model free RL. Here we are taking both the approaches. We are combining both the approaches of model based RL and model free RL. So now we are going to see what is Dyna Q architecture. So far we have seen the differences between model based and model free. Now Dyna Q is combination of model based and model free. We have one well known example for model free RL, that is Q learning. So we have an example for model free, that is Q learning. Now how we are going to follow this, how we are going to do this Dyna Q architecture means, so Dyna Q architecture, what it does, first initially we know the Q table. First initially it will take some Q table. From the Q table it builds a simple model. So from that model of the environment, it does some simulation. So we are going to see step by step how this Dyna Q architecture works. Dyna Q architecture works based upon three important words. One is Q learning, second one is model the environment, third one is planning. Planning means here simulation. Before Dyna Q, we already know what is Q learning. Q learning means, we all know it is a Q learning means we all know it is a model free. Model free means we know, actually we have seen some many examples like this, actually grid boxes and all. So here agent is here. What is the aim of the agent? He wants to go to the goal state. So agent can go here, can go from here, can go down here. Like by taking left action, right action or down action, it can go to the goal state. But how an agent will decide which action it has to take, whether left, right or down, based upon the Q values. So in model free, in Q learning, we are calculating the Q values. For every state we are taking some action, we will calculate the Q value. Here Q value, 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 Q value. So based upon the highest Q value, the agent takes the decision. Suppose here the Q value is high, then agent moves left. Suppose the Q value here it is high when compared with these three things, left, right, down. Then agent moves from here to down. So same in the Dyna Q architecture, first initially it initializes some Q table. After initializing Q table, what it does, based upon the Q table values and all, it model the environment. So it creates some environment. So Q table means some real-time experiences. From real-time experiences, it creates some Q table. After creating the Q table, same, then it builds the model based upon the Q values. After this, the Q values are there, then it simulates the experiences based upon the Q value. Now here it performed some, here it is in one state, by taking some action, it will get some reward. So based on this scenario, it will simulate same kind of experience. Again, suppose agent is here. It has taken some action. Based upon it, it will get some reward and it is moving into the another state. The same thing again, you are simulating the experiences. So by simulating more number of experiences for the existing Q table, so then the agent learns more faster. So it will converges more faster. So now we are going to see the pseudocode of this Q learning algorithm. So this is the pseudocode. Dyna Q architecture. So we all know, see what will happen in the input, we all know step size alpha, we have to take 0, 1, epsilon value should be greater than 0, number of planning steps n greater than 0. Here planning means we have seen it follows 3 steps: Q learning, model, planning. Planning means simulation. How many simulations you can perform? It should be greater than 0. So definitely more than 1 or more than 0 only we have to simulate the experiences. So this initial input, now initialize. What is our first step? First we have to initialize some Q table. After initialize Q table, what we have to do? We have to model that Q table. We have to build or construct the environment. So alpha, we know it's a learning rate. So we are adding every time, after for every state and action we are adding new information, but it should not fully override the information. Based upon our alpha value, it should be minimum only. Now epsilon, we all know epsilon, we have seen in unit 1 also. It is a greedy strategy for selecting action. Like for epsilon we have seen it is an exploration and exploitation. We have seen one example, a person is visiting many restaurants. Like first what he has to do, he has to explore, then exploitation. So suppose epsilon we have taken as 10%, means out of 100, 10 times he explores different kind of restaurants, and remaining 90 times he exploits which restaurant is good. This example we have already seen long back. So same example we are using. So epsilon, it is for exploration and exploitation. Now initialization is Q value, then model, then this one. See now, so model means we are stores this current environment. Like what happens for this, what happens if it is in this state, by taking this action it is moving. So what happens? So everything you are model the environment. Now after that what we are doing, so forever do means it runs continuously till it converges, it runs continuously. So now first one is S, current non-terminal state. We know S means it is a current state. A means we know action. How we are going to take the action? By using epsilon value. By probability of epsilon for exploration, 1 minus epsilon is for exploitation. Then what we have to do? Then we have to take an action A. After taking an action, we have to observe reward R. It means we are moving into the next state S dash. Then this is Q learning algorithm. So initially first what we are doing, Q learning we are finding the Q values. So now by using this formula, we are finding the Q values. After getting the Q values, we are modeling the environment. So it means whatever the experiences which we got in this Q table, we are store those experiences in the model. Suppose when you take an action A in state S, you get some reward R and you're moving to the S dash. So everything, entire thing you have to model that environment. Now the next is for n times to do. What is this n times? So this particular block, it is for planning. Now Q learning is completed. Then model is completed. Now the third one is planning. This particular loop is only for planning. For n times means how many times you are simulating the experiences. First S means randomly previously observed state, randomly action previously take. So see, here we have seen example. Now see, from agent is here. So an agent can take any state. He can take any action to move, then he will go to another state. So here whatever an agent takes an action, based upon the action, he will get some reward. Based upon that action, he will get some reward. Based upon the reward, he will go to the next state. So now this kind of step again you are simulating here. R, S dash model S, so you are simulating everything. For everything whatever an agent does, the same thing again you are simulating that experience. Then this will rotate, this loop will rotate until it reaches some convergence or it completed. So if you see, the first one, Q learning, is based upon trial and error, real-time experiences. You are building one Q table. Again, based upon those experiences, you are updating some model. It means you are storing all these experiences. Then based upon this, you are simulating some experiences. Just to make, it means you are faking those experiences. Whatever it has done, you are faking again. Then the model, the Dyna Q algorithm, learns very fast. It doesn't wait for real experience. It uses some hallucinations, some imaginations too. So this is Dyna Q algorithm.